Welcome to this video. It's for Leaving Cert Ordinary Level Maths students, and we are talking about how we can calculate the slope 4 different ways. So where you're going to see slope most of the time is coordinate geometry and calculus, but also your knowledge of graphs will help you along here as well. So let's look at the first method. So you have 2 points. You're going to use the formula y2 minus y1 over x2 minus x1, and that is in your log table, so you don't have to know it off by heart. And really and truly you can use any 2 points on that line. It doesn't matter which 2, any will do. So let's look at our first example. So they're asking us here to find the slope of the line AB, where A is minus 1, 1 and B is 1, 3. Please label your points x1, y1, x2, y2. It's super important. We literally pop the information into the formula and we get our answer of 1. Always be mindful of your signs. Let's look at the second example now. So if you look at the points that we were provided with, you can see that we have a K in one of them. So we're missing some information. So we just do the slope calculation as normal because we know the answer should be 3 over 5. So we create a little situation where we sub in, and again, sub in that K, have confidence in your abilities, you're well able, and we get an answer of K minus 2 over 5. We know that that should be equal to 3 over 5. You've got 2 options here. You can actually use your algebra skills here and solve for K, or you can just compare them and state what the value of K would be. So I'm going to use algebra because obviously I love it. So I take K minus 2 over 5 and I let it equal to 3 over 5, and I work to get rid of the fraction. So I multiply across by 5 to do that. And then when those 5s cancel out, I'm left with K minus 2 equals 3. And I work out that K is equal to 5. Now it's time to look at our second method for finding slope. So we're going to use the equation, and when we get the equation of a line, we're going to rearrange it into the form of y equals mx plus c, and we find that an m value represents our slope. So let's look at a quick example. So we have the line 2x plus y minus 4 equals 0, and we're asked to find its slope. So I simply rearrange it, and I see that my m value is minus 2. So my slope is minus 2. Moving on to another example here, we have 2x minus 3y plus 6 equals 0, and again we're asked to find the slope. You rearrange it, you move the things around bit by bit. You'll quite often see that your slope value is actually a fraction, so you just need to be mindful here that it's minus 2 over minus 3, which we can say is 2 over 3 because we want it to be positive. A minus by a minus gives us a plus. Now let's move on to the third one, which is when we have parallel and perpendicular lines. This information is really important. The only connection between 2 parallel lines from a coordinate geometry point of view is that their slopes are the same. So if they're telling you it's parallel or perpendicular, they're giving you a hint to use this type of information. You can see my explanations there for the parallel and the perpendicular lines and what the relationship is when we're talking about coordinate geometry. So let's look at a quick example. So let's investigate if the line y equals 2 over 3x plus 4 and 2x minus 3y minus 5 are parallel. State the facts. We know that if they're parallel, their slopes are the same. So let's find the slopes of both of them. We find that we get 2 over 3 in both situations, so therefore they are parallel because their slopes are the same. It's as simple as that. So let's look at another example. Again, we have a K value, we have something that's missing. We've got the line M and the line L, and we've got points on either of those lines. And they ask us, if the line L is parallel to M, find the value of K. And you can see the little 2 straight line symbol there indicating parallel. So again, if they're parallel, they have the same slope, so we get the slope of the line M, which does involve a K, but again, we work with it. And we go ahead and we find the slope of L. Again, we label all our points and we sub them in carefully and accurately. And we get a value of 2 over k minus 1 for the slope of M and 3 over 6 for the slope of L. Again, similar to a previous example, we'll use our algebra skills here. We multiply across by k minus 1 and 6 to eliminate our fractions. And once we do that, we're left with 6 multiplied by 2 equals k minus 1 multiplied by 3. This is clearly a linear equation. X is on the left, numbers on the right. Or in this case, k is on the left, numbers on the right. We solve that out and we get k is equal to 5. Let's look at another example that involves perpendicular information. So we've got the line M, we've got 2 points, and we're just simply asked to find the slope of any line that's perpendicular to M. So again, we know the information that's relevant about the perpendicular points or the perpendicular lines. We find the slope of M. We see that it's -1. We know that if we flip it and change the sign, we get an answer of +1. That is the slope of any line perpendicular to M. Okay, let's look at one more question on this. So the lines 5x minus 4y minus 20 equals 0 and 4x plus ty minus 6 equals 0 are perpendicular. Find the value of t. You can clearly see that these types of questions are very popular. So we know the relationship between the slopes when they're perpendicular. So let's go ahead and get the slope of the first line. And we see that it's -5/4. Let's go get the slope of the second line, and again, let's work with that t, and we find the slope is -4/t. Now, we know the slope of the second line, that it has the t involved, should have a slope of +4/5 because of the perpendicular situation. So, -4/t should be equal to 4/5. So let's solve that using our algebra skills. So I'm going to multiply across by t and 5 to eliminate those fractions. And I end up with a nice little linear equation. I move it around and I solve it for -5. Let's look at the fourth way to find slope on our course. And this is finding the rise over run. To be honest, rise over run in my book is a last resort, and when you have no other option, I definitely prefer the other 3 versions instead. It can be used for problem-solving questions, more for a higher level than ordinary level, but it's definitely something that you should definitely have in your maths toolbox if you need it. Let me show you a little diagram here of how we actually find the rise over run. So I'm just drawing a line here, and how we find our rise over run is we actually extend over and up in order to create a rise and a run. And when you're doing a rise over run lines, you want to create a little right angle triangle against the line that's originally there. Calculating rise over run, we get 3/3, we get 1. But remember, it's a negative slope, so you must put in that negative value yourself. And that's actually one of the main reasons I'm not the biggest fan of rise over run. It's a last resort for me. Make sure you subscribe to this video and put on the notification bell so you can be notified when my next maths video is live.